Hello, everyone, and welcome to section 2.4 in Precalculus, complex numbers. So you already know that we can't take the square root of a negative number. So sometimes we have a negative underneath the radical, and somebody decided we needed to have a better notation for that. It's just not pleasant to write. Don't think about it as a new skill. Think about it as just a notation. If you have two of them, the square root of -1 times the square root of -1, that would be I squared. And that would be equal to -1. Because think about it, the square root of -1 squared, the square and the square root cancel, and you get -1. If you have I cubed, that would be I times I squared, and since I squared is -1, this would end up being -I. And I to the fourth would be I squared times I squared, which would be -1 times -1, which would be +1. So these are the four different things I'd like you to memorize. I is just I, it doesn't change. I is just I. But if you have I squared, you should always change it to -1. If you have I cubed, it can be simplified to -I. And if you have I to the fourth, it can be simplified to 1. A complex number is a combination of real and imaginary numbers. The standard form of a complex number is A plus BI. This is the real part, and this is the imaginary part. Together, they're called a complex number. So the square root of -50, when you're doing radicals, I don't know how you were taught in Algebra 2, but I personally always break it down into parts I can simplify and parts I can't. So for 50, I think to myself, well, 50 is equal to 25 times 2. It's also equal to 10 times 5. But 25 is a perfect square. Neither 10 nor 5 are, so I don't want to break it down into that. But 25 is a perfect square, and 2 is not. So that allows me to simplify it to 5 square roots of 2. So what about the negative? Does it go in the I can simplify it or in the I can't simplify it pile? It goes in the I can simplify it pile. So you can simplify the negative. It comes out as an I. And when we take it out, we write it after the number. So it would look like that. Now I'm going to just tell you right now that your book is going to write this as 5 square roots of 2 and then the I, which makes sense. That's how we would write, 5x. We usually put the variable at the end. But number one, this is not a variable. It's an imaginary number. And number two, if you have even a little bit of sloppy handwriting and you make that too long, then it's going to be wrong. So my recommendation is that you put it before the square root, and then you don't have to worry about getting it wrong. On the next one, of these 6, you could break it down into 3 and 2, but neither one of those are perfect squares. So the only way you can break it down is the negative and the 6, which gives you 2 minus I square roots of 6. So the 7 already is simplified, but if they want you to write it as a complex number, you could write it as 7 plus 0I, but that is not necessary. It's already in a perfectly fine form. And finally, -2I. So if you ever see an I with a power, go up to your little chart there at the top. I squared is -1. Now your book, again, is going to write it as -1 minus 2I. That's standard form. It's kind of like putting things in descending order. It's nice, but I am not taking off for this. This is a perfectly good answer in my opinion. Okay. There you go. All right, most people really love this section. I's just like X's. So you have 4 plus 7i. The parentheses in this case aren't doing anything. Parentheses can do two things. They can group things together, which it did. It's saying I have this complex number and this complex number. But when there's a plus between them, you can get rid of them and they have no effect. So I'm going to put my numbers with my numbers, my i's with my i's, and that's it. This is a nice section. If there's a negative before the grouping symbols, then it's saying that you want to subtract everything in there. So don't forget to distribute that negative. You are more than welcome to do that in your head. But if you skip straight to the answer and your answer is wrong, I can't give you partial credit. This step allows me to see what you were thinking. There are no more i's. And again, you don't have to write plus 0i. Again, this is worth it to you in order to get partial credit if you make a mistake. To just take, it only takes you, what was that, like 6 seconds? To just go ahead and distribute the negative to everything. So now let's see, my 3 i's cancel. Oh, my 2's cancel. Yeah, just negative 5i. Aren't these great? 3 plus 2i. These parentheses were unnecessary. These parentheses were unnecessary. And these are necessary because it's saying you're subtracting the entire thing. So make sure you distribute that negative. I'm going to do the numbers first. 3 plus 4 minus 7 is 0. So I'm not going to do the numbers. And then 2i minus I, also 0. 0. Now, when a number is directly in front of the parentheses, it means multiply. So you can continue to do things just like you normally would, like it was an x. Negative 8 plus 12i. If you can do things with x's, you can do things with i's. What would you do if these were x's? You would FOIL. So you still want to FOIL. First, outer, inner, last. You must simplify I squared. You are not allowed to leave it there. I squared is equal to negative 1. So this becomes 8 plus 10i minus 3. 3 times negative 1 is minus 3. And my final answer is 5 plus 10i. Again, these parentheses don't have a plus or a minus between them, so that's how you know it's multiply versus what we were doing a few minutes ago. So first, square root of 11 times the square root of 11 is just 11. Outer minus the square root of 77. Now, see how they put that I on the outside? I'm just going to move it to the front because I feel better about that. And then same thing here. Plus I square roots of 77. And then the last times last is going to be negative. The square root of 7 times the square root of 7 is 7. And the I times the I is I squared. Remember that I squared is equal to negative 1. So this is going to become 11 plus 7, which is going to be equal to 18. You better watch out on this one. A lot of people distribute the square. Do not distribute the square. It is the number one mistake in this section. Make sure that instead you write it out. 3 plus 2i. So that gives us first, outer, inner, last. Remember that you can't have an I squared, So this becomes -4, which gives me 5 plus 12i. And the last one in this section. First, outer, inner, and last. You can't leave the I squared, so this becomes +4. The 6i and the 6i cancel, so you get 13. So two problems that I want you to notice are the ones where you have what we call a conjugate. A conjugate means that you have basically the same thing, but one's a plus and one's a minus. Not the whole thing, just the middle term. So notice the 3's are both positive, but then the 2i changes. Here's another example of a conjugate. Square root of 11 plus square root of 7i, and square root of 11 minus the square root of 7i. What's always going to happen, if you recognize it in advance, you can actually skip this step because the inners and the outers of conjugates will always cancel. So it's always just going to be first times the first and last times the last. The inners and the outers of conjugates always cancel. So when I look at this one, if you notice that they're conjugates, then you can say, oh, I can just do first times the first and last times the last, because the inners and the outers should always cancel. You can't leave an I squared, so that becomes +1, which is 2. Again, I see the conjugates, so when I'm doing FOIL, I just have to do first, outer, inner cancels, and last, which is 16 plus 9, which is 25. So we're going to use this fact to rationalize the denominator. So you might remember rationalizing the denominator being for square roots. You can't have a radical in the bottom. We're going to use it to get rid of the I. You're not allowed to have an I in the bottom. But if you look, whenever we use the complex conjugate, we never ended up with an I because the I gets squared and that makes it go away. So I'm going to multiply the top and the bottom by the conjugate. I get 12 plus 6i on top. So now I have an I on the top. You might be thinking, what's the point? But there is a point. If you take higher level math, you will see it. Inners and outers cancels. That was the whole point of choosing the plus 2i. It made the inners and the outers cancel. Minus 4i squared. You're always going to end up with an I squared, which means you'll always be able to simplify the bottom. 16 plus 4 is 20. Okay, next warning is simplifying. So a lot of people think that you can just cancel two things, especially if only one of them looks like it cancels. So when people have 3x plus 5 over 6, they think that they can reduce these two, but you can't. You can't do anything that has addition and subtraction, so be careful. If you want to reduce this, the safest thing to do is to put it into two separate fractions. And then 12 over 20 dividing by 4 would be 3/5. And 6 over 20 dividing by 2 would be 3i over 10. Okay? If you see in the back that they've kept it as a single fraction, I actually don't think that they do, but if they did, then you could just not reduce this as much. Reduce this one first and then leave this one as 6/10, and you could have that. I'll take either answer. They're both good, but you really shouldn't leave it as the original because it can be reduced. Okay, so again, how do we get rid of I in the denominator? You multiply by the conjugate. So I'm going to multiply by, it's still a 2, not a -2, but then it's a plus I. And make sure you show you're doing it to the top and the bottom. Now technically, this needs another parenthesis here because it's not just I times 2 plus I. So again, on the bottom, why did I choose the conjugate? So I could just do first, outer and inner cancel, and then last. On the top, I am going to have to FOIL out first, outer, inner, last. You can't leave the I squareds, so this one becomes a -1, and this one becomes a -1, which is a +1. So I get 4 minus 1 is 3 plus 4i over 5. Writing it as 3 over 5 plus 4i over 5 is not necessary, but not wrong. So you can choose. But I'm just going to box this one because I got to it first. Why do any extra work? If a is a positive number, the principal square root of the negative number, negative a, is defined as this. So we've been just doing it with -1, saying that that's I, but this is I square roots of a. So in other words, you break it down into the parts you can do, which becomes I, and the parts you can't. Why is this important? It's mostly just for this. It's because people take these two and they just multiply them together. I'll write it off to the side so you can see it. Is not equal to the square root of -36 or positive 36, which would then become 6. Instead, you have to simplify them first. So this is I square roots of 3, and this is I square roots of 12. And when you multiply them, you get I squared square roots of 36. The I becomes a -1. The square root of 36 is 6. This is the answer. So do you see what happened? If you multiply first, you could have two negatives, make a positive, and then you've lost the negative. So make sure you always change to complex form before multiplying the insides. Okay? Okay, I would say that this is the hardest problem in the section. Not where people make their most common mistakes, that's in distributing the square. But the hardest question is right here. You can only add like radicals and i's. So if you have 3 square roots of 2 plus 5 square roots of 2, you have 8 square roots of 2. Nobody ever questions this. People get that. But somehow, when they don't have 2 square roots of 2, they think they can still add them. You can't. They have to be the same. So we're going to try and simplify this. So I break it down into parts I can do, which is always the negative, and parts I can't. So the 48, if you have to, make a little list of perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Do any of those numbers go into 48? Well, 4 does. 48 is equal to 4 times 12. But then if you happen to notice that 12 still contains another 4, then it would make you realize that the better choice is 3 times 16. So this does have a perfect square, but this one still has a perfect square. So that doesn't make it the best choice. Think about it like this. If somebody said, oh, can you reduce 50 over 100? The best choice is to divide by 50. Can somebody that divides by 2 say they reduced? They can, but they're going to have to reduce more. So it's better to get right away to the best choice. Same thing here. So the best choice is the 16 and the 3. You might not know your factors very well, but you can write this list on your appendix and then just keep it handy and just use your calculator to figure out what numbers go into 48. As soon as you get to 25 and 36, they're not going to go into 48. So you really don't have to check that high. With 27, I look at my list. I'm not going to have to go above really 16, 25. So it's really just 1, 4, 9. And of course, 9 goes in there. 9 times 3. So the square root of 48 becomes 4i square roots of 3. I'm taking this minus right there. And then the square root of negative 9 is 3i, and then square roots of 3. So they do have like i's and like radicals. So since I have 4i square roots of 3, and I'm going to subtract 3i square roots of 3, I end up with 1i square roots of 3. The 1 is not necessary, just like we don't normally write 1x. All right, so I'm just going to tell you right now, hardest question. You must simplify them to like radicals if you want to be able to add them. And sometimes you can't. Sometimes you can't simplify them. This one is not the hardest question, but again, I said it earlier in the hour, this is the most common error, and that is to distribute the square, but always do this. And as we were originally starting this section, remember, we're going to change it to an I first. So I square roots of 3, negative 1 plus I square roots of 3. And now we can do it. So first, outer, inner, and last. The square root of 3 times the square root of 3 is just 3. So I have I square roots of 3 and another I square roots of 3. I can say I have 2 I square roots of 3. I squared becomes negative 1. You're not adding, though, you're multiplying. This is I times the square root of 3, so it's I squared times 3. So negative 3, and that simplifies the 1 and the negative 3 to negative 2. Okay. You guys doing good? Solve each of the following. So there's two kinds of solving with x squareds. When you see an x squared in an equation, set it equal to 0 and factor. This is going to be the case 9 times out of 10. There is only one exception. If there is no x term, then just get x squared alone and take the square root. Little algebra 2 here. So I see an x squared in my equation. It's already set equals 0, but first of all, I can't factor it. And second of all, I can get the x squared alone. So I can write x squared is equal to negative 4, and then I take the square root. X is equal to, don't forget your plus or minus the square root of negative 4, which now we can write as plus or minus 2i. So all the time, kids try to apply that to this situation, but you can't take the square root of, of this. The square root of x squared, this you can do. But the square root of this, yeah, you're not doing that. So when you see an x squared in an equation, always set it equal to 0 and factor. 3x squared minus 2x minus 5 is equal to 0. Fortunately, there's only one way to factor this. It's got to be 3x and x. Now you do have to think about the 5. Do you want the 5 multiplied by the 3 to make 15? Or do you want the 5 not multiplied by the 3 so you can subtract? I want it not multiplied by the 3. So now my inners are 5x, and my outers are 3x, and my goal is a negative 2x in the middle. So to get that goal, I would make the 5 negative and the 3 positive. So the 5 negative and the outers, which would create the 3x positive. That's how you factor. So either 3x minus 5 is equal to 0. And this one you can probably do in your head. You don't need to write that step. Either x is equal to negative 1 or x is equal to 5/3. Okay? So these are your two main ways of solving an equation. So not every problem in the world is going to fall into these two categories. You're definitely going to have questions where there is an x term, but you can't factor it. Or possibly it is factorable and you just can't figure it out. So your backup plan is the quadratic formula. This is your backup plan. I would love for your first attempt to be to factor, but this is a great backup plan. So in case you've forgotten, I'm just going to do it real quick. The quadratic formula says that if you are given ax squared plus bx plus c equal to 0, somebody way smarter than me figured out that the answer will always be the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Again, with the canceling and simplifying that we talked about earlier, some people write it like this to make sure that they do not accidentally cancel the b with the 2a, which is a very common mistake. So this one, I'll just tell you, is not factorable. So this is my a, this is my b, and this is my c. This only works if it's equal to 0. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So I do see that there's going to be some simplifying. So right away, I think to myself, I'm going to write this as two separate fractions. And that way I don't have to worry about making a mistake. So let's see, what do we get underneath this radical here? 4 times 9 times 37 minus 36 negative 1296 all over 18. So you can see if that's a perfect square just by checking on your calculator. To the 1/2, it is 36 times 36. So this is 36 times 36. If it hadn't been a perfect square, I would have made my list. 1, 4, 9, 16, 25, 36, etc. And I would have seen what number went into it. But I always check to see if it's a perfect square first. So this is 6 over 18 plus or minus. So the square root is of 1,296 is 36, but since there's a negative, it's 36i over 18. These do reduce differently. This is going to be 1/3, where this is going to be 2. There are two answers. The square is what tells us that there's going to be two answers. So this is really 1/3 plus 2i, and then 1/3 minus 2i. But you're not required to write it out. I just wanted to point out that they are separate answers. Would the quadratic formula have worked even if it was factorable? Absolutely. But now that we see the negative under the radical, we are definitely sure we could not have factored it. Okay, if you would like to try the next quadratic formula on your own, I will tell you the two answers and you can try that. 3/7 plus or minus the square root of 34 over 14i. And the last one is 1/3 plus or minus I square roots of 23 over 3. And same thing with this one. Sometimes people write it as a fraction and then I, but if you had written it like this, I squared, which is how I would have done it. I was copying it from the book. That is also really good. Okay, so I chose these two examples because I actually think you already know how to do the quadratic formula. I picked him because you would not have been given these two in Algebra 2. These are significantly harder. When you have fractions like this, the best idea is to get a common denominator and then clear the fraction. So I would change these all to 16s. 14 out of 16x squared minus 12 out of 16x plus 5 out of 16. And then I would multiply both sides by the 16. And when you multiply by 16, that literally just leaves you then with 14x squared minus 12x plus 5 is equal to 0. You do not want to be sticking fractions in your quadratic formula. That would be really hard. So x is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So I've said this before, I would change this to separate fractions. I think that you'll be more successful. And let's quick do this. 14 minus, not 14, 144 minus 4 times 14 times 5 gives me negative 136. So the question is, what perfect squares are in 136? So this is where you make your little list. 1, 4, 9, 16, 25. If you're wondering, where am I getting this list? This is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. I mean, it's 136. This is not going to be how high it goes. And then I kind of look to see, well, do any of these numbers go into it? So you can start off with something high, like 136 divided by, let's try all the way up to 64. That seems a little ambitious. Nope. 136 divided by 49. Nope. 136 divided by 36. I didn't want to try that because that seems silly. I know I'm not going to try 25. 136 divided by 16. No. 136 divided by 9. No. 136 divided by 4. Ugh. So I usually try and get the highest one, but it turns out the 4 if I started at the other end. So I'm going to break this down into parts that I can do. Oops, that's a plus or minus. I'm going to break this down into the parts that I can do and the parts that I can't. I'm just going to go ahead and reduce this. Dividing by 4, this becomes 3/7. This becomes 2i square roots of 34 over 28. Now the 28 does cancel with the 2. These are all factors on top. 2 times I times the square root of 34. And multiplication cancels with division. That's why it's allowed. So this becomes I square roots of 34 over 14, which is your answer. This next one is on here for the same reason as number 2, not because I don't think you can do the quadratic formula, but because you've never done it with a decimal. So let's not do it with a decimal. Let's multiply everything through by 10. I personally would rather do that than have a decimal. So this becomes 45x squared minus 30x plus 120 is equal to 0. I think you'll have an easier time reducing in the end if it's like that. So actually, these are really big numbers. Can anybody think of something smaller I could have done? So I picked 10 because it moved the decimal place over, but it is 4.5. So this is kind of like 9, not kind of like it is, 9 halves. I could have just multiplied by 2. So if I thought of it as 9 halves x squared minus 3x plus 12 is equal to 0, I could have just multiplied both sides by 2, and that also would have cleared my fraction. So that gives me 9x squared minus 6x plus 24 is equal to 0. Slightly better numbers. I'm not going to bother to factor it, only because I know that, that it's not factorable. All right, x is equal to opposite of b plus or minus the square root of b squared. So it's the whole thing. If you're typing into your calculator, you might accidentally do negative 6 squared. It's going to tell you it's negative 36, but it's not. It's the whole b that's being squared, so it's your job to remember the parentheses. B squared minus 4ac all over 2 times a. Once again, I'm going to separate it into 2 separate fractions. And I'm going to figure this out here. 36 minus 4 times 9 times 24. 828. So again, I think to myself, okay, now this one's a little easier. I see the 8 on the end. It makes me think I bet 4 goes into it. So of this list, I'm not just going to randomly try numbers. I'm going to try 4, 16. I'm not going to try 25. I'm going to try 36 again. I know it didn't work out last time, but not probably 49. 9 times something could make an 8 on the end. So let's see. All right. So I, as before, started with the highest one, even though it didn't work out last time, and the 36 did work. So I break this down into the part I can do, negative 36, times the part I can't do. So when I divided, I got 23, which is not a perfect square. This becomes 6 over 18 plus or minus 6i square roots of 23 over 18, which becomes 1/3 plus or minus I square roots of 23 over 3. Okay, so I tried to give you some where you had a fraction, where you had a decimal, try to give you some help in breaking these down into parts you can do and parts you can't with really big numbers. And as you can see, I've been teaching math for a long time and I still didn't think of the best one right away. There's a little guess and check there. Okay, we have 3 more problems. These are just some extra examples that I thought you might find tricky on the homework, so I thought I'd do them with you. The first one is to remind you of something we did just so briefly at the beginning of the hour, which was to say that I squared is negative 1 and I cubed is negative I. So I'll write those down again. I is always I. You can't simplify it. I squared always becomes negative 1. I cubed always becomes negative I. And I to the 4th always becomes 1. Make sure that's in your appendix. So this becomes negative 4 plus 2i. That's what they meant by simplify. You're not allowed to leave I squareds and I cubes. On this one, the goal is for you to remember that you must simplify it before you do anything. So this is, if I wrote it out, it would be this 6 times. I square roots of 2. I square roots of 2. I do not actually expect you to write this out 6 times. I square roots of 2. Instead, I expect you to think in your head, okay, this is going to be I to the 6, and then the square root of 2 times the square root of 2 is 2. The square root of 2 times the square root of 2 is 2. And the square root of 2 times the square root of 2 is 2. And 2 times 2 times 2 is 8. Now, I to the 6 is not on our chart. We only went up to I to the 4th. But you can break it down into two separate ones. So you can break I to the 6 down into I squared times I to the 4th. Or I to the 3rd times I to the 3rd. But I picked these two because I like I to the 4th. I always use I to the 4th when I can. Because I squared is -1, I to the 4th is +1, and then I still have my 8 from all those square roots of 2. So the final answer is -8. So there's parts of this section that are super easy, but there are some little challenges like that. Last one. Again, this is the same as times 2i times 2i. I don't have to use FOIL. 2 times 2 times 2 is 8. And then I cubed. So when I first talked about getting rid of the I in the denominator, we only did ones that had a conjugate, like this. And so you multiplied the top and the bottom by 2 minus I. And I think that that probably went pretty well for you. If you get something like this, you can get rid of the I just by multiplying by one more I. See, look, I have I to the 3rd, right? If I multiply the top and the bottom by one more I, I'll have I to the, oh, I didn't want to multiply yet. If I multiply by one more I, I'll have I to the 4th. And do you remember what I to the 4th is? I to the 4th is just 1. So this becomes I over 8, or 1/8 I. It's the same thing. Okay, so these last three show you that there might be some that are a little tricky. Make sure that you do your homework. After you watch these notes, you should do your homework before class time. That way you have a chance to ask questions on any of the ones that were just a little bit tricky. All right, have a great day.